All right, we've got a lot happening in this one. So in this one, we're going to run an intrusion detection system and a firewall, and we're going to download exe files and then view our logs and view packet captures. So the first part will be, we're going to use Mininet to build our little network. We're going to have basically an internal and an external network. We're going to start the SNORT IDS and then watch its log and watch the signatures fire as we go ahead and download an exe file from our simulated internet. We're going to view those log files, and then we're going to start up the IP tables firewall and watch that, watch how that behaves, and then actually create a firewall rule of our own to stop people from downloading that exe file from the internet, because we wouldn't want them to do that. And then when we're done with all of that, we're going to look at our packet capture that we created in the first part to try to find out what happened. So what was downloaded during this time, right? We had this suspicion that something not good happened or something we didn't want to have happen, and then we're going to verify that in Wireshark and see what exe was downloaded. So we'll start in our CyberOps workstation. You'll log in as analyst. And the first part is going to be that we've got to start up our little Mininet network, and the network topology itself this time won't show up like it has in the past. It's much bigger. That topology is that first picture in your lab at the top. So let's go ahead and start our topology. And it's long. There's a good chance I'm going to have a typo somewhere in here. Sudo space /lab.support .files /scripts /cyberops _extended _topo _no _fw.py, and hit enter. Enter the password for analyst. Ooh, not a typo. I think that's pretty surprising, actually. So that's started. Now we're going to go ahead and open up our terminal for our R1. Xterm space R1. R1's is going to run both our SNORT IDS and our IP tables firewall. We'll start with first we'll start SNORT and watch that behavior. Look at that log. I'm actually going to make this a little wider. User that's logged in as root, and that's indicated by the pound symbol there. Let's go ahead and start our SNORT IDS. So /lab.support .files /scripts /start _snort.sh, and hit enter. Wow, not a typo there. That's surprising. And so now SNORT started up. We want to open our host 5 and our host 10. So H5 and H10. H10 will simulate the server on the internet that's hosting the malware that we're going to download. So we'll go back here, xterm H5 and xterm, xterm H10. So our H10 here is going to be our web server that has our malware on it. H5 is where we're going to do our wget or webget request to pull the file from host 10. And then we'll look at the logs on R1 as the file or as that transaction is taking place through the SNORT IDS. So let's start our malware server on H10. And move my cursor again. .lab, or ./lab.support on H10 ./lab.support .files /scripts /mal _server _start.sh. Now we want to verify that the server's running, so we'll use netstat dash TUNPA. And we should see, in fact, that it is running. We remember from a previous lab, and I think it even says probably in this lab, that NGINX is our web server. So we can see right now that it is running. And we've got to open another terminal window so that we can watch the snort log in real time as we download that file. We can't use the same one over here. Snort's running in this one, so we've got to download another one. So we'll go back to our terminal window. Move this down. And our terminal window has Mininet running. We'll type xterm space R1. And again, I'm going to make the window wider. I like it better when I could see most of the stuff on one line rather than having it wrap. So I know in their lab they have a bunch of little windows. If that works better for you, that's great. I'll go ahead and do that. And so then I like to not have as much wrapping text as possible. So now we're going to use the tail command with -F so that in real time we can see the snort logs. So in our new R1 terminal window, type tail -F space /var /log /snort /alert and hit enter. You may have some, if you've done something with this before, they should have actually cleaned out, but if they don't, it's not a big deal because we're just looking as they come in real time. So we'll look at ours as they come up in real time when we do it. So there could be nothing in here, that's fine, and if there's something in here right now, that's fine as well. What we're looking for is the new stuff anyway. Now let's go to host 5. I got find host 5. I suppose I could just go up here, our node H5. Come here, node H5. There you go. And we're going to pull the file from our web server on H10. wget. And what I want to see down here is I should see a new alert. So wget space 209.133.132.nimda.amm.exe. So we're going to pull the file, and it finished successfully, and our new alert was generated. Prior to this, even though I had some in here prior to pulling that though, I had 3 others. So the new alert is this bottom one. Now you can review that alert to answer the questions, and my stuff will be a little bit different than yours. The port being used was 6666. Our file did download, and we did generate this alert. Now if you didn't, I suppose you'd write that in there, but you should have. So if you didn't, that means we typed something in wrong. From the alert, you can find the source and the destination. So the source is here, and the destination is here. Your source and destination, or your source port number will be different than mine most likely. But here would be the source port number being used. Here's the destination port number being used. Your times will also be different, but here's where you find it. So basically I'm just looking at it, say here you can find it. Here's a date, here's a time, here's the message you're actually getting. All right, so now we want to do it again, but this time we want to use TCP dump to create a packet capture. So we're going to download the file again, but this time we want to capture the whole thing as it happens. And then later we're going to look at that capture to see if we can figure out which file was downloaded. So on node 5, we're going to start TCP dump. TCP dump space -I space H5 -ETH0 space -W nimda dot download.pcap space ampersand. So we're going to capture traffic on H5's Ethernet 0, and we're going to save that to nimda.download.pcap. And we use the ampersand at the end to tell it to run in the background. All right, so go ahead and hit enter. And then what we want to do is we want to download that file again. So if we just hit enter again to get our prompt back, hit the up arrow, or you can type the wget again, but you can hit the up arrow until we get back to the command to download the file. And go ahead and download the file. So hit enter, and it downloads again. Now this time we've captured all that using TCP dump. Now we want to stop our capture. So the first thing we got to do is type FG to bring that TCP dump process to the foreground. Enter, and then Control C to stop it. All right, now we were able to download the file. Let's say we don't want users to be able to get to that server and download that malicious file. So now what we're going to use is we're going to use IP tables. We're going to add a rule to the IP tables firewall. So IP tables is just a Linux-based firewall that uses the concept of chains and rules to block or forward traffic. So we are going to create a rule inside the forward chain to stop people from downloading that malicious exe file. So that's going to be an R1, so we're going to run that firewall on R1. So we'll click, we got to open another R1 window. So we'll do xterm R1. So we got a third one running now. And the first thing we want to do is just look at the IP tables as it currently is. So we'll do IP tables. Did I move my mouse? I don't remember. Yeah, I did. IP tables space dash capital L to list all the chains, and if anything's not specified, so it'll list the chain. Dash L will list the chain I can specify it, or it'll just list all of them if I don't specify at all. Dash V to give us more information. Hit enter. This currently has 3 chains running: the input, the forward, and the output. So the input chain is used or handles traffic entering the firewall that's also destined for the firewall. The output chain handles traffic that originated in the firewall and is destined for somewhere else. And the forward chain handles traffic that originated somewhere else and is just passing through the firewall. So all 3 are running. And now we want to go ahead and create a rule that's going to stop folks from downloading that malware file from our simulated internet server. Because that traffic is not originated in the firewall and is going to pass through the firewall, what we're going to add the rule to the forward chain. So IP tables dash I, capital I. That says we're going to insert. Where are we going to insert a rule? We're going to insert the rule in the forward chain. Dash P to specify the TCP protocol, so dash P space TCP. And then dash D and the IP address, so the packet's destination is 209.165.202.133. See if I didn't make sure I didn't. And then we want to specify the destination port, and then what are we going to do with it? We're going to drop it. So dash D port for destination port, and that is the 6666. And what are we going to do with the traffic? Dash J space drop. So assuming I spelled everything correctly, we are going to add this rule to the forward chain that's going to drop packets destined for this address on this port. Go ahead and hit enter. And I did not type something right, so I gotta look. Oh yeah, if you look, I forgot the other dash, so it saw it as 2 dash Ds. So I'm just gonna hit the up arrow, hopefully, up arrow, and we'll go back and add the other dash for our destination port. Now we should be adding our rule to our forward chain. There we go. Now we add our rule to our forward chain. I'll go ahead and view our IP tables again. So IP tables dash capital L dash V, and this time we should see our new rule in our forward chain. So we're good. We have just added a rule to the firewall that should block downloading of that malicious exe file. So let's go back to our host 5 and just verify that it works. Node host 5. You're going to hit the up arrow, or you can retype it till I get to the wget command that we typed earlier and hit enter. And now we can see it's not downloading the file. I mean, it happened so quickly last time, we can see it right away. So our firewall is working. Our firewall is blocking that traffic through. So we'll go ahead and hit Control C to stop it, because we could sit here forever. Our firewall did what it's supposed to do. So we looked at snort, we looked at the snort log, we looked at IP chains, or I'm sorry, IP tables, added a rule to the IP tables firewall to block our download, or to block anyone's download. We could have been less specific and just blocked everything going to that server as well, instead of specifically the port. Hit Control C to just stop it. And that's it for this part. We're going to look at our captured packet, or our packet capture, wow, in the next part. So we got to go through and clean up Mininet. So we'll close this stuff. So didn't have to, I just like to. You have to clean up. And we hit quit in the Mininet terminal. After it stops, type sudo space mn-c and put in the password for CyberOps Analyst. And it should clean up everything for us, and we're done with the Mininet portion on it. We're going to move on to trying to get the executable, or find out what the executable file was that was downloaded from the packet capture that we got in our TCP dump. So we want to go into, we want to see first that the file is there. So we'll go to change our directory to the lab support files of PCAPs. CD space lab. Assuming you're already in Home and Analyst, which you should be, but if you want to double check, you just do a PWD. Yep, Marty in Home Analyst. So inside Home Analyst, we want to go to lab support files. So CD space lab.support.files/PCAPs. Hit enter. Let's do a long listing of that. And we should see our NIMDA download PCAP file. So that was the file that we created earlier in the lab with our TCP dump. Now let's go ahead and open it with Wireshark. So Wireshark -GTK space nimda.download.pcap. I'll move my mouse. Wireshark nimda download, just making sure I typed it right, and hit enter. That should open up Wireshark and that file. There we go. So there's our packet capture. We actually want to look at the fourth packet first. The first three are our TCP three-way handshake. And you guys have viewed those a couple times now, so we should be pretty good at that. So let's highlight our fourth packet and make this window a little bigger. And we're just going to open our hypertext transfer protocol arrow here, expand it, and we this is what we knew because we did it, but we can see in here that a file was grabbed using get. The file was nimda.amm.exe. So what we already suspected is true. The full request, so it can show you exactly what the file was, or at least the name of the file, the port being used, and the IP address of the server that was accessed. Now, because this is all TCP, we can do the follow the stream that we've done before to get a little more information about it. So let's go ahead and do that. We'll click on the first packet, the very first TCP packet, right click, go down to Follow TCP Stream, and that's going to open the new window that allows us to see the whole stream. And if we look through the whole thing, some of the things that we already kind of knew. But if we scroll down, this is the file itself, so all these little characters and whatnot are the file. The file is binary, it's all sent in binary. So Wireshark doesn't really know how to handle that, so this is how the output looks. If you see clear text words, it's probably some sort of message or something that's in the file, like an understandable, readable message. But if we keep scrolling down, we can find out a little more about the file. This is in your challenge, and I'm not going to give you exactly the answer. I'm just going to show you, because I think you'll see it. Come on, scroll down. There we go. We can see what kind of file this actually is. So in real life, we're not actually going to we're not going to be playing with the actual NIMDA malware. So this is the exe that they used instead. And what is that exe? When you do the lab, you fill that out for me. But here it is. So it's not the actual NIMDA malware itself, it's just another exe. And we were able to figure out what that is by following the TCP stream. So now we want to extract the actual downloaded file from our packet capture. All right, so close this up. Now here's our actual get operation. So we're going to just highlight that, because now what are we pulling? We're going to pull the executable file out of the transaction. So highlight it, then go to File, go down to Export Objects, HTTP, and wait a moment for it to find it. And then we'll highlight the file we want, click Save As. I'm going to go back, click on the Home tab, then click on Analyst, and click Save. Do we want to overwrite it? I'm going to just let's change the name, because there's multiple here, and that could happen. Let's see if we can put a 4 at the end of this. And then click Save. There we go. So just know we saved it with a little bit different name. You may or may not need to. I would have expected some of that would have cleaned up, because the virtual machines should be reverting to their golden master, but maybe some things just aren't getting cleaned up as planned, or it was part of the master and I didn't realize it when I took the snapshot. Anyway, I digress. It's fine. You can just change the name. We saved the file. Now just remember that when you do your listing, you're going to see it as a little bit different file name. So we'll close all this up and go back to our terminal window and go to Home/Analyst, where we saved the file, and hit Enter. And then do an ls-l to see if our file is there. And this is the one that we saved because there was already one on here. Oh, actually, this might be on there because it's in the original. It's part of the snapshot, or part of the snapshot in case you didn't do. No, that's probably why. Not that you need this long explanation, but this was probably on here because it's in case you didn't do the first lab before doing this lab, you could still do this lab. Anyway, here's the file we saved. So it is there. Let's try to find out a little more about it. You can do specifically our file or the one that was already there as part of the snapshot. So file space w32.nimda amm4.exe and hit Enter, and that gives us even more information. We know that this was a Windows executable file. Right. So kind of neat. I mean, you were able to, we looked at the snort logs, we created a firewall rule, we captured the traffic of a download while downloading an exe file, and then we were able to pull that information out of our packet capture. So that's it for this one. Our next step would be to analyze it a little more. I mean, at this point, you know a little bit about it. You wouldn't want to run it on your regular system, so maybe run it in a sandbox to try to learn a little bit more about the malware. Now, if this one wasn't malware, but if it was, that would be a way to go once you had this exe file to actually run it and see what happens.